question 3 for everyone, and so on and so forth. So that I'm, whatever rubric I have in my head is the same for everybody. So that's why I like to do it. Now I know what you're talking about, Amir. And here we go, lecture 19, no time to lose today. Which is Wednesday. What's the day today? May 6th. Bhavneet, let's worry about that. Let's now first finish what we need to know for the final, or it doesn't matter where the final is if we don't know what to do. So let's just start, and I will put up and I'll answer all those questions, okay? So here we go. And so the thing is, and we're going to start here. So now we already know that this particular series, I think I can hear something, so I'm going to mute you all. And we already know that this particular series which can be written in notation adds up to 1 over 1 minus x. We also are aware that this is true if absolute value of x is less than 1, meaning -1 is less than x is less than 1. So now tell me, this series is centered at and you can unmute yourself and say, so this series is centered at. Very good. The radius is
1.
Very nice. Answer my question to you, is there's a power series? And the answer should be yes, it is a power series. Why? Because it's just a polynomial. Power series is of the form or so we never did anything like that. So I'm just going to start. This is going to be my first example today, and here it goes. So to find the radius and interval of convergence, by the way, the interval of convergence on this series is going to be -1 to 1. It's a geometric series, so I don't need to check the ends. This part already tells me the ends. So to find R and I, which is the radius and interval of convergence, we use ratio test. So my first example is going to be a series that is not centered at 0, and we are just going to work through it. And so talk to me about this one. This was good. The power series was okay. The ratio test was all right. And so
Yep.
here's my, okay, thank you. So here is the series. Oops. I don't know where that please is coming from. Okay. So to just get an idea of this one, so tell me this one is centered at, so you're going to fill in that blank for me. And I'm going to write it out just to get an idea of what's going on. So it is 3 to the 1, x plus 4 to the 1 over 1, 3 squared, x plus 4 squared over square root of 2. I don't even have to simplify. I just want to get an idea of what it looks like. So this is centered at Very good, Tiffany. It is indeed centered at -4. So is this a power series? Yes, I'm going to say it's a power series because I can say it's a polynomial where we have powers of x plus 4. So you have powers of x plus 4 to the 1, then powers of x plus 4 squared, then cubed, and so on and so forth. So we have that. So that's why it's a power series. If I want to find the radius of convergence of power series, I use the ratio test. So this is going to be limit as n approaches infinity, x plus 4 to the n plus 1, square root of n plus 1, so as I have been working, I'm going to collect the like terms together. And square root of n over square root of n plus 1. So the next thing I'm going to do is, so please tell me, does this work? I always like collecting the like terms together. It makes it run fast. It just tells us, it lets you quickly see what's going on. So did that help?
Yeah, I think so.
Thank you, Russell. I think the kids are working. So this will be 3 then. I'm just going to write here something, and you're going to tell me if this and from here I'm going to remind you limit of product of limits. So this is what I actually do. I start. So what is limit n approaches infinity of 3?
3.
Thank you. Limit of this is just going to be, do not forget the absolute values. It's just going to be absolute value of x plus 4. And limit of this is going to be
0.
do better than that.
Oh, 1.
Thank you, sir. So ratio test says what? Ratio test says if this limit, this is your L, if this limit is less than 1, then it converges. So in other words, I'm just going to take this and I'm going to solve for x, because what was this whole game about? When I'm finding the interval of convergence, when I'm finding this, what am I finding? I'm finding for what x does this series converge? Keep writing it till it kind of goes in and you are very clear as to what is the radius and what is the interval of convergence. So that is the question that you're answering when you're answering the interval of convergence. Why am I mentioning that? So when I come here, I'm going to say solve for x. Solving for x will give me the interval of convergence. But remember, at this point, I've got to check the ends. So let's start. So this is going to be absolute value of x plus 4 is less than 1/3. And that would mean what? Negative 1/3 is less than x plus 4 is less than 1/3. So I'm going to subtract 4 from both sides. So this is going to be negative 1/3 minus 4 is less than x is less than 1/3 minus 4. 4 is 12/3. So this gives me negative 13/3 is less than x is less than 11/3. So now I start drawing my picture, which is, you said the center was at negative 4, which was, I could write this as negative 12/3. This is negative 13/3. This is negative 11/3. You know what happens after this, it diverges. How do I know? Because ratio test also says if this is greater than 1, it diverges. So I know this diverges and I don't waste time on it too much. Inside, it converges. So I just want to check the ends. I just want to check these two. So I can't tell you the interval, but I should be able to tell you the radius of convergence. So any idea, or is the radius of convergence? This is the center. How much are you going away from that center? So radius of convergence is and whenever you're
I
ready.
want to say 11/3.
Remember, from the center, there you go, Karen, that's correct one. Remember, Russell, from the center, it's how much do you need to walk to get to the either end. So if you are at 12/3, negative 12.
Yeah.
So 1/3 then. And we are going to check the ends. Because I know what happens here everywhere else except two places, which is negative 13/3 and negative 11/3. So I'm going to come back here. I'm going to put in x equals negative 13/3. X equals negative 11/3 in what? In this series, which was 3 to the n. X plus 4 to the n over square root of n. N goes from 1 to infinity. So if I put negative 13/3 in there, 3 to the n, negative 13/3 plus 4 to the n over square root of n, you're going to tell me what I get here. Remember, 4 is 12/3. And you're going to tell me what I get here, which is n equals 1 to infinity, 3 to the n, negative 11/3 plus 4 to the n over square root of n. And so this is going to be n equals 1 to infinity. So can I say that this is going to be 3 to the n, negative 1/3 to the n over square root of n? And you're going to check that for me? Similarly, this one is going to be 3 to the n, 1/3 to the n over square root of n. Questions? Are we okay? Very good. So this gives me and this gives me now tell me convergence or divergence. So which test, by which test are you saying now? And so on and so forth. So no, you don't have to do all the steps. In other words, I'm saying do all the steps in your head, check them as you do it. So very good. So this is a P series, I agree. So what do we have? N equals half, which is less than 1, so it diverges. What about the other side? Very good. So this is an alternating series. And the verdict here is very good. It converges. Yes, Amir, it is conditional convergence. Yes. That was the part I was going to touch upon again on Monday. Yes, it is conditional because if you take its absolute values, then it diverges. But if you take it as an alternating series, it converges. So yes, it converges with the condition on it. And Karan, I'm trying to address that. So going back to this one, as Amir points out, if you take for this one, if you take its absolute values, Karan, then you get this one, which it diverges. So we don't have absolute convergence. So you go back to the series itself. That's when it is an alternating series, it converges. That means it has got conditional convergence. It converges with a condition on it. And what is the condition now? The terms have to be alternating in sign. Because if they're all positive, then we know it does not converge. And so you can refer to that flow chart. That is conditional convergence. So we're going to go back with this verdict. Go back where I draw that diagram. And what do we have here? Here we have, sorry. So here we had diverges. Here we had converges. So I'm going to say the interval of convergence is going to be what? Negative 13 thirds to 11 thirds. And that's it. And so this is your interval of convergence. And this is going to be the radius of convergence. So you are saying that this series converges only if you pick x between negative 13 thirds to 11 thirds. And negative 13 thirds is what? About negative 4.3 something? So, oh, sorry, yes, and negative 11 thirds. Thank you, Karen. So questions, because I'm just going to do this example. I think it's just a little bit an extension of the ratio test, which you've already done. So the only part here is you've got to solve for x and check the ends. So you just got to solve for x, check the ends, and you should be okay. And that brings us to heavier stuff, which I do want to do today. And this is where I started with at the beginning. But before I close this out, no questions about this problem? We're okay? So I'm going to pause a minute, give you a minute. Anything about this one? So I guess everything looks all right. So I'm going to go to the next idea. So here is the next idea. And I'm repeating myself. I already know a series, a geometric series. Now I have many names for it. A power series, centered at 0, is equal to 1 over 1 minus x. I want to emphasize again that this is a function of x. So this is a power series centered at 0, which is equal to f of x. So I don't want you going into that. Amir, just unmute yourself, say what you got to say, and we've got to move on. Because this is the most important concept that you're going to deal with. So one more time, you are writing f of x as a power series. Now, not only that, once you write that, you know the radius of convergence, which is 1, and you know the interval of convergence, which is negative 1 to 1. So in some ways, I want to say that when you're writing f of x as a power series, this interval of convergence is the domain of f. So as I'm writing this, are we clear about what I'm saying? And you should be absolutely clear. Otherwise, you're going to get confused as we move on. So any questions about the things that I just wrote there? And when I'm saying this is the domain of f, I'm only talking about when you're saying that this f of x is equal to this power series. And we've gone over that, Karan, because this is a series centered at 0. So at the beginning of the lecture, we talked about this. So you can look at this one. This is a geometric series. So you know that the radius is equal to 1. Does that answer your question? Great. So if everybody is here, then the next question is, if I can write this function, can I write other functions as power series? And I'm not kidding, just pay extra attention to this because this is going to be the crux of your final. So can I write other functions as series? More importantly, why am I writing them? Oh, because ultimately, I still do not know how to integrate functions like this one. And if I could write this as series, then I can integrate them. So the first question is, can I write other functions as series? Yes. And then we're going to explore how. But the other question should be, what is the purpose of this one? The purpose of this one is, if I can write functions as series, then I can integrate them. They serve as solutions to differential equations, which is going to be 2 classes from this semester. Ordinary differential equations. And that is why you're learning it. So for me, it's not just this semester. This is the thing that you're going to carry on forward. So again, I'm emphasizing this. We can write this function of a series. Can we write other functions as series? The answer is yes. Well, how do we do it? How to do it? This is calculus. We have done this before. So I'm going to say we are going to use algebra. Algebra is a big word for me. So when I say algebra, I'm going to say substitution. I can multiply, divide series by a constant. And this shouldn't surprise you because I make you write the terms. So the big one is coming up. This is the big one that I'm writing in red, that you can also differentiate and integrate to write other f of x as a series. I'm going to give you an example of every single one of them. So we're going to start with the algebra, and then we are going to get to this one. The question should be, oh, what about the radius and interval and convergence then? For this part, we're going to use a theorem. So leave some space here. I'm going to come and do the theorem. For this part, leave some space here. I'm going to come and fill all of these up when we do an example. Are you with me? Because I want all of you to completely stop writing when I do this example. So I'm going to wait. I'm going to let you get there. Okay, thank you, Nara. So Army is ready. How about the others? Teachers can click on yes, or I just want to know if you're not ready, rather. So Karan says 1 second. I think Trent was almost there. Russell is a yes. So he's ready. So Frankie, okay. Okay, great. So I think I've heard from most. So here we go. So when I use the algebra, here is the idea. Oh, geez. Okay, I'm going to have to do this again because So this example is of using algebra. So when I say use algebra, I mean it in the most liberal sense of that word. So how do we do this? I always start with this series. So this is like a puzzle. This is like, I already know. I know this. At this point, just for this example, I'm going to start writing it this way. I'm going to remind you again that this is only true. This is true. This is true for -1 less than x less than 1. If it is for others, it's not true. And you can quickly check if I put x equals 2, for instance, then 1 plus 2 plus 2 squared plus 2 cubed is not going to be 1 over 1 minus 2. That's ludicrous. All right, people. So that is not right. I already know that. So I'm going to erase this. So no, it doesn't work for x equals 2. It only works for x between -1 and 1. So I'm going to use this. And we're going to have some fun today. So I'm going to use this. To write 1 over 5 minus x as a series. Completely stop writing and just observe and just go with me in what I'm saying. So remember, I'm using this to write this function as a series. It's sort of a new function. So when I say algebra, what do I mean? I'm going to go up there. I want to use substitution. I can multiply, divide series by a constant. So here is my prep and here is my idea. So here is the plan. The plan is first work with the function itself. So the function is 1 over 5 minus x. So can I write this as 1 over 5, 1 minus x over 5? Can I write it like that? You can unmute yourself today and just say yes or whatever. So no questions there. That means what? I just factored out 5. The question is, why did I do that? Because now I'm looking at this one and I'm looking at my model. And what substitution do you think? So in my model, I'm going to replace this x by x over 5. And then I'm going to get only this part of the function. And then I'm just going to multiply the whole thing by 1/5. Notice what you're saying. So if this is the thing, then this is the thing here, isn't it? So you are replacing x by x over 5. So I'm going to do it here. So this will be 1 over x over 5 plus 1 over x plus 5 squared. And this is going to be 1 over 1 minus x over 5. So far, so good. So talk to me now. Isn't this still a geometric series? What is the ratio? What is the common ratio? Very nice, Karan. So the common ratio is x over 5. And what did we say? This will converge when what? X over 5 is less than 1. That means what? And I'm going to write it here. So I'm talking about this series now. Oh, this is still a geometric series. Because how did we get that? We replaced x by x over 5. So now we are saying, oh, x over 5 is less than 1. This is the common ratio. That is when geometric series converges. That means what? Absolute value of x over 5 should be less than 1. So absolute value of x should be less than 5. That means x is between negative 5 to 5. That is the interval of convergence. And so, if you're saying between x equals negative 5 to 5, if this series converges, when I multiply it by a constant like 1/5, will it still converge? Very good. And that's it. And that's pretty much done. So here we go. So now I'm saying, I'm going to copy it down there. Which I could write in notation as n equals 0 to infinity x over 5 to the n is 1 over 1 minus x over 5. That doesn't look like my function. So now I'm going to multiply both sides by 1 over 5. So when I do that, remember it's just 1 over 5th times this whole thing. So I get, I'm going to write something. You're going to tell me if that makes sense. What is the radius of convergence and what is the interval of convergence? So take this down, answer these two things, and we are ready for the next big one. Now, Karen, it is not, no, Tiffany, the radius is not 0, the center is at 0. So go back up. Very good. So the radius is 5. Why? Here. And the interval of convergence is from So I'm going to bring this all together, but before that, I want to do that theorem. So this theorem is on page 748. So any questions about this one? Okay. And so I'm just going to call out people randomly. Sadhna, Jezebel is not talking to me today. Cecily, Almarie, Tracy, Ilian, the rebel in the group. Okay, so this is a theorem. And I'm going to just write the theorem for you in my way. This is the theorem in the book. So what does that theorem say? It says if a power series can be written equal to a function. In other words, So can you hear me?
Yes, we can.
Okay, thank you. So let me restart this. And here we go. Oh, goodness. Let's mute me on the ship. Okay. I think I'm going to, when I get very depressed, I'm going to read those chats, which means I have to read them over and over again. Oh, not so far, Cecily. It does go in that box, but I just want to put something else in that box. So this was the starting of the series. This was the start of the story, which was what? That you take a function and you write it as a power series. Well, how do you write it? Right now, you just know one way of writing it. On Friday, you're going to learn even more ways of writing it. So right now, you know one way of writing it, which is playing with the algebra, which is manipulating the only series that you know, which is what? That 1 over 1 minus x. So, and you should know the radius and interval of convergence. If your question was, how do I know the radius and interval of convergence? I'm going to say, use the ratio test. This is where I was. Is everybody caught up? So is everybody there with me? Okay. Then the story continues. Then what? And then a very powerful theorem, and you should be very happy with this theorem. So it says that if you can write this way, then you can integrate and differentiate both sides. Well, you are saying, how I know how to integrate the function. I know how to take the derivative of the function. What about the series? Oh, they're saying for the series, just integrate and differentiate each term. That is what they call term by term. Just integrate and differentiate each term. This is called term by term integration and differentiation. The punchline is coming up, so wait. But you ought to say that when I integrate and I differentiate f, I get new functions, which is integral fx dx, which might be a totally new function. And then I get f prime x dx. What do I mean by that? Oh, very simply, I'm just saying if I integrate f, which is sine x, then I get the integral of f, which is negative cosine x. If I differentiate f, which is sine x, then I get the derivative of f, which is cosine x. So, in other words, they gave me different functions. They gave me totally different functions than what I started with. Then the question is, what happens to this radius and interval of convergence? And this is where the punchline comes. So he says that the radii stays the same. So don't worry about it. The radius stays the same. For the interval of convergence, just check the ends. And say, I'm going to go way back up there, and I'm going to say, okay, the other way to do this is to integrate f of x as a series. So when you differentiate or integrate, the theorem says that r stays the same. For I, check the ends. What about for this one? Oh, look at the substitution. If you replace x And here I want to say something. So I want complete attention from all of you. So do I have it? Or are you still writing? Because once we fill this box, it's going to make today's homework and the final really nice. So each and every one of you, do I have your attention or wait for a minute? Why is Sadhna not talking to me today?
We're all depressed about the test scores.
Some of them shouldn't be. And you can ask around.
I'll get a poll going.
Yeah, some of them shouldn't be. This is what I'm going to say to you. You know your scores. If you have scored about a 35 out of 40 and you do not talk to me, I'm going to start taking points away. There was mutiny on the ship. There is mutiny on the administration part as well.
Okay.
Karan, you are the instigator. So don't drag us into this conversation. There is long now. Now they know. Now they can find alphabets to type on their keyboard. Good. So you know if you scored well and you do not talk to me, I'm taking points off. And she smiles. Yes, Amir. There you go. And I am indeed smiling. So I want everybody's attention now. So here we go. So in the substitution, and when I say substitution, what am I talking about? I'm talking about this geometric series, 1 plus x squared. I'm always talking about this one. If I replace x by x over a, where a is a constant, what about this series? What is the interval of convergence? -1 to 1. Can you tell me when you replace x by x over a, what will the interval of convergence be? Remember, this x is replaced by x over a. So the interval of convergence will be?
-1 to 1.
This is for this one. You're almost there. But remember, all these x's are now replaced by x over a. I'm trying to grab that pencil. Very good, Cecily. -a to a. And let's make the other answer right, your answer right, Joshua. So Joshua will be right when we replace x by ax. And then Joshua is right. Then the interval will be -1 over a to 1 over a. Because in that case, Joshua, what will happen? Oh, absolute value of ax has to be less than 1. Remember, a is a constant, so you can take it out. Even if it's negative, you know the absolute value is going to be positive, and Joshua is going to write that time. That's it, people. If you are, then I'm going to continue with the story. I'm going to remind you that story. Off we go. So here we go. So we started the lecture, which is, you're always going to do this thing. N equals 0 to infinity is 1 over 1 minus x. We used the substitution. We replaced x by x over 5, then multiplied by 1/5. That was our plan. And when we did this to this side, and when we did this to the series, we got and the function was 1 over 5 minus x. Remember, why this manipulation? Because we wanted to use algebra here. So the manipulation came from here, from the function. And we know the radius is, what is the radius then? 5, right? Because, x over 5. So I already know from my box. And the interval is -5 to 5. Now the theorem says I can integrate this. So let me start writing. So what does this side look like? Oh, this is x to the 0 over 5, x to the 1 over 5 squared, x squared over 5 cubed, x cubed over 5 to the 4th, right? Equals 1 over 5 minus x. I'm going to say again, this is the function. This is your series. When is this true? This function is equal to this sum. What sum? Infinite sum, when you pick x somewhere between -5 and 5. So I'm just going to take one side of it. The fx is 1 over 5 minus x. So tell me, when I integrate this, what will I get? So integral 1 over 5 minus x dx will be what? And so let's remind ourselves. 5 minus x is u, negative dx is du, so dx is negative du. So I'm going to get, after we do all of that, I'm going to get oh God, it's not happening again. So are you still there?
Yeah, we're still here. Can you not see people answering in the chat?
No, because everything vanished from my side. So you are right. This is negative ln of 5 minus x plus c, right? We can't forget c. It was an indefinite integral. Right, everybody?
Yep.
Okay. So, okay, I integrated the function. And anyway, I knew that was the easy part. Now let's integrate this one. So to integrate this one, here's the trick. Here is how I want you to see. So stop writing and just look at what I'm trying to do. So this is 1 over 5 plus 1 over 5 squared x plus 1 over 5 cubed x squared plus 1 over 5 to the 4 x cubed. So tell me, when I integrate this series, and how do I integrate this? I integrate each term. So tell me, what is the integral of 1/5? There you go. So the integral of this one is going to be 1 over 5 squared x squared over 2. 1 over 5 cubed x cubed over 3. 1 over 5 to the 4 x to the 4 over 4. Right, people? So I notice what? I notice that the constant has nothing to do with the integral. We are integrating the terms. We are integrating this. We are integrating this. And what happens? Oh, the exponent goes 1 up. And you divide by the exponent. So now I'm going to do something else very interesting. I'm going to write this in notation. So in notation, this turns out to be, and I'm going to go back up there. So this turns out to be summation n equals 0 to infinity. 1 over 5 to the n plus 1. Remember, these were these ones. X to the n plus 1 over n plus 1 equals negative ln of 5 minus x plus c. So I'm ready to write that this is that series. Everybody with me? And now literally drop your pencils and say, did I need to do this? Because look at this. Isn't this was your x to the n. Isn't me just using this integral formula and just putting the constant aside? Yes, Lucas. And now pick it up as well. Don't litter. Don't make your mum pick it up. So are we there? Meaning I'm just using the formula because I know it is the constants have nothing to do with it. Reminding you, you're saying this is true when what? X is between -5 and 5. So tell me, to find C, that constant of integration, what value of X between -5 and 5 should I use so that the X disappears and I can just find C? So what value can I use there? There we go, Karan. So we will plug in X equals 0, both sides. So that gives us what? So if you are going to plug in X equals 0 both sides, remember you plug in X equals 0 here if you don't want to see it here, but you know this is just going to be 0, equals negative ln of 5 plus C. So what is C? Oh, C is ln 5. And some very important thing happening. So I'm ready to write it then. So ln of 5 minus x. So let me write it in a nicer way. 5 to the n plus 1, n equals 0 to infinity, equals negative ln of 5 minus x plus ln 5. So I can say that ln of 5 minus x equals ln 5 minus and notice how I'm changing the variable here. So I'm going to say ln of 5 minus x is ln of 5 minus summation n equals 1 to infinity. And now we are going to look at what we can do there. So questions? So I know you must be writing, so write and so Karan, you tell me what happened to n plus 1. Because you have to look at what we did there. It was starting at 0, this is starting at 1. There we go. And so can you change the limits and write? Is it the same series? Yes. If you want to check, I would say write it out, which some of you just did not bother to do it on the test, but no, write it out. Takes you a minute. You don't even have to compute, but you have to see that they are one and the same thing. So the next question then. So let me see what I've done that. Oh, we have written ln of 5 minus x as a series. So what is the radius? Oh, the radius is still going to be 5. What about the interval of convergence? Oh, I just have to check the ends, meaning I have to put in x equals 5, I have to put in x equals -5 to see what happens. But the theorem tells me the radius stays the same, and sometimes that is just enough. Now, you should be wondering that your calculator, how does it compute ln of 2, for instance? Because then it goes ln of 5 minus 3 is ln of 2, which is, it just adds the infinite sum. So the calculator is about adding and subtracting. It's not about knowing what an ln function is. So it's got a computational value there. So if you want to know ln of 2, then you are just going to do this. So any questions?
Not for me.
Oh, we wrote it in n equals 1 form because sometimes, your calculator doesn't understand that initial value. The initial value is the computer science. But yes, you can always write a computer program where you can say the initial value starts at 0. But when you ask, your calculator can add the first 20 terms and give you a good approximation to what ln of 2 is. You get a more powerful device. It can add 100 terms. 50,000 terms. The more terms your machine can add, the more closer you're to the actual value of ln2. Does that stay well? So here we go. So here is the other thing I wanted to do with you. So starting with this one. Remember, we can also start with this one as n equals 1 to infinity, x to the n minus 1, right? It's one and the same thing. You can define where your limits are going to be. In other words, where you start and where you stop. We're stopping at infinity, so that's taken care of. But here is the one thing that I wanted to do with you. I don't know if I'll be able to finish it, but this is the one that I really, really want you to see. So I want you to start here. And I want you to write a series for 1 over 1 plus x squared. So let's see if we can do that. So I'm just going to say, let's first replace this x by negative x. So if I do that, I'm going to replace on both sides. So this is negative x to the n equals 0 to infinity. And I get 1 over 1 minus negative x, which is 1 over 1 plus x. Agreed? And so I'm just going to say this is n equals 0 to infinity, negative 1 to the n, x to the n is 1 over 1 plus x. We're getting that. It's all because of this current. You have to look at what you're writing the function for. Now I'm going to replace this x by x squared and this x by x squared. So I get so far so good. Okay, nobody seems to be saying anything. So I'm just going to say here, what was the radius of convergence here? It was 1. What was the interval of convergence? Negative 1 to 1. What did you do? You just replaced x by negative x, and then you replaced it by x squared. So what happens to the radius of convergence? Oh, you are just going to keep it the same, isn't it? The radius of convergence is still going to be 1. The interesting bit, and I want to get to the interesting bit, we have that, but everybody okay till here? I'll come to the radius of convergence a bit later, but right now, writing this function as a series, are we okay till here? No questions from anybody.
Yep.
So Sadhna, you're still not talking to me and you know you're in trouble. Long, Bhavneet, Karan, Trent. Oh yes, you talk, Karan. Who else is there? Aaron. Ivan. You should be talking to me. Jonathan, you should be talking to me. Yes, We're building up the series that we want. Yes, in fact, Trent, I'm going to go for you. You decide a function, whatever comes to your mind, and you start building it up. Very good. Now tell me, people, when I integrate this, what do I get? What is integral 1 over 1 plus x squared dx? You know you're going to need it. So what is this integral? It's not O. What is this integral?
ln of 1 plus x squared.
There you go. So now it's tan inverse x.
Oh. Yeah.
And so now look at the part. Now, if I integrate this, I get tan inverse x plus c. We know how to integrate this, isn't it? Forget this. Just integrate this one. So this is what? N equals 0 to infinity. Negative 1 to the n. X to the 2n plus 1 over 2n plus 1. That's it. That's tan inverse x plus c. The radius is 1. So tell me, what value of x should we plug in to find c? To find c, we can plug in x equals what?
Zero.
Long if you talk to Karan, I'm taking points off. So x equals 0 then? So if I put x equals 0 both sides, then what do we have? We have 0 equals tan inverse of 0 plus c. What is tan inverse of 0? So I heard some calculator clicks. That is exactly what I would do. Yes, it's 0. And so c is 0. Oh, so now you're saying negative 1 to the n x to the 2n plus 1 over 2n plus 1 is tan inverse x. The radius is 1. So I can put any value between negative 1 to 1. Remember, I don't know about the n's, but I can put any value between negative 1 to 1, isn't it? So here is one value that I want to put. I want to put x equals 1 over square root of 3. So tell me, if I put x equals 1 over square root of 3, what is tan inverse 1 over square root of 3? And so tan inverse 1 over square root of 3 would be? Very good, pi over 6. Very interesting, isn't it? So now you are saying, if I put x equals 1/3 both sides, negative 1 to the n, 1 over square root of 3 to the 2n plus 1, over 2n plus 1 equals pi over 6. Ah, very interesting. So 6 times negative 1 to the n, 1 over 2n plus 1, square root of 3 to the 2n plus 1 is pi. If it was up to me, I would make each and every one of you to write a program to compute the value of pi. How do you think your calculator computes the value of pi? It does not take the ratio of circumference over the diameter. It doesn't even know what these things are. So how do you compute the value of pi? This is it. It's the sum of this series. Is there only one way to do it? No, there are many ways to do it, because you can also write sine inverse as series. And that is the value of series, people. And that is what I like to show you. So I'm just going to do some algebra bit and let you go. So this is going to be n equals 0 to infinity, negative 1 to the n, 2n plus 1, I can write this as square root 2m times square root of 3. And this is going to be just 6 over square root of 3. Negative 1 to the m. 3 to the n. 2n plus 1 equals pi. And today, yes, I took a little bit of more time. You can also simplify this, but I'll let you go. Took a bit of more time because we lost some time in that thing. We did 1 over square root of 3 first because it belongs in the interval. Second, it gives us the value of pi. Because I knew tan inverse of 1 over square root of 3 is pi over 6. What I wanted to show you was that how you can use series as a computational. Yes, Sadhana, there are many more series that add up to pi. And that is why we are still computing the values of pi. If you look at the values of pi, Sadhana, you have to understand the more terms your machine can add, the more you get to the values of pi. So right now, I don't know, I used to know this, but if you add 50,000 terms, your machine can add 50,000 terms, then you have a better value of pi than my machine, which can just add 20,000 terms. And that is why people are still discovering that values of pi, the decimal of pi. And you have one way to do it. So these are sort of my office hours now. And ask any questions if you want, but this is where we're going to go. Yes.